Hello everyone, welcome back. Now that the softwares are all up and running properly, we will start doing econometric analysis, the real thing. So let me move on to my presentation here. This first lesson here is to level up the knowledge of the students of this course. So the idea here is to present the initial concepts of econometric analysis so everyone has a nice solid foundation for us to move on and get to know other methods and how to apply them. So um, first to start, I would like to talk about three foundational concepts. So before we start, I would like to talk about three fundamental concepts in econometrics before we enter the methodology itself. So now we're going to talk about variables, the difference between correlation and causality, which is something very important if you're writing an essay or an article, a paper using quantitative data, and the types of data analysis that we use in econometrics. So the first thing, it's important to know that we use two types of variables, the dependent variable and the independent variable. The dependent variable is the one that we want to discover, is the variable that suffers the result of other variables. Usually when we have an equation is the little y, letter y, at the beginning of the equation. That's the dependent variable. And usually the idea is to answer the question, what are we trying to predict? The letter y represents a variable of something that we are trying to predict or understand how that variable is affected by other variables. And the other variables that are not the dependent are the independent variables. So the ones that cause or are associated with the dependent variable. Okay, we're gonna see this in detail, but just for you to know, when you have an equation, the first letter, usually a y, represents the dependent variable, the one we're investigating, trying to find information about. Correlation and causality. That's another thing, tricky concept that we have to have clear before we start. So correlation is when two or more variables, behave in a similar way. Those correlations can be negative or positive. If one goes up, the other one goes down. That's negative. If both go up, that's positive, like selling cars and selling fuel. Those things tend to walk together. The numbers tend to go are closely related. So that's a correlation. The fact that two variables move in the same direction doesn't mean that one variable is caused by the other. Both variables might be influenced by a third variable, and that's really hard to prove when we're talking about econometrics, because you have to exclude all the other possible explanations to say that one variable is caused by the other. Like one thing leads to the other for sure, and nothing else explains it. As you see, it's even to explain it sounds a little absurd, but that's the idea, and that's probably the main thing that researchers try to do nowadays in most fields, in economics, in social sciences, in medicine, that are trying to experiment with new drugs, is to make sure that that drug, that molecule is the one responsible for the response that they want. So that's causality, and we're gonna have one full module talking about this at the end of the course. But you have to understand, have to have it clear now that correlation is one thing, and causality is much harder to explain and to prove. Mathematically, you don't actually prove. You have to argue to show that you try to find all the other possibilities for that explanation, and none of those are real. So the one that you're proposing seems to be the best one. Most articles go that direction. And then I'm going to start talking about some of the main methodologies that we use. Linear regression is probably the most used, and then that's the form of the variable I was talking about. This is the dependent variable. This is the independent variable, and this is like the formula of a line. Now, if you plot that, it's a simple line. But most models to predict the behavior of a certain variable will have this idea. Obviously, those coefficients, they will change. The variables that you're going to put in the model, they will change. And sometimes we use variables of the past of the variable itself and other variables that we want. And that gets a little more complicated. You can get to the size of a matrix. That's the base of the analysis that we make in econometrics. Is one dependent variable and other independent variables according to a coefficient that we're going to estimate. So the OLS is the most common method used to estimate coefficients in linear regression. And the idea of this model is to find the line that best fits the data by minimizing the sum of squared differences or residuals. The idea, it's conceptually, it's simple. You calculate the residual for each data point, you square the residual, and then you find the line that minimizes the sum of these squared residuals. Why OLS? Because it provides the best linear unbiased estimates, the blue, under certain assumptions that we're going to talk about more here later. And when we talk about analyzing data in any type of analysis, it doesn't matter what type of analysis you're doing, you have three ways of analyzing data. The first one is cross-sectional data. It means that we take observations of multiple entities at a single point in time. It could be entities, could be companies, could be individual people, persons, it could be countries, something that you can compare, right? So different countries, or if you're trying to get information for a new drug, for example, you're going to test that drug in different people. So you have individuals. Those things, it's a line, right? That line is one entity. And when you have many entities and one single point in time, a single year or a single day or a single month, something like that, you have cross-sectional data. Here, I put an example of countries in 2022 by GDP growth, just for you to see what a cross-sectional data looks like. The next type of analysis is the time series data. This type of data is when you observe a single entity or a single variable or a single individual or country or whatever you're trying to observe for a longer period in time. So I took an example here, Colombia's GDP growth from 2020 to 2024 each year. This type of analysis is very common when we're looking at some specific data like GDP growth, financial data, stock prices, options, things that have a high frequency data for stocks, for example. The price changes every second depending on the stock. So you can look at it like every day or every hour or every minute, and then you can make a time series of the price of a stock during a certain period of time, and that's it's a time series data. And the last type of analysis is the panel data. Panel data is when you take multiple entities over multiple points in time. So it's like having many series combined. However, we don't use panel data for high frequency data. As I was saying, if you take stock prices, for example, and you have stock prices let's suppose that I'm looking at stock prices every 10 minutes of some stock I'm interested in, it becomes nearly impossible to analyze. Let's suppose I'm going to analyze 1,000 companies looking at their data every 10 minutes for 1 year. That would be like a massive amount of data that will probably be useless because there will be too much information, too much noise, and I don't think we will be able to find some tendency in such high frequency data for so many companies at the same time. So when you're choosing your data, you have to think of something that makes sense, right? So panel data is is probably the most used type of analysis when we're talking about countries, companies in data that are annual data, semestral data, sometimes monthly data, it depends. But for social analysis, most of the times, if we're looking at countries, states, or things that don't change very much, then panel data is probably the most appropriate. And I would say that articles in the area of economics and finance, those areas, usually panel data is the methodology that people like the most, because you're more likely to find interesting results, to find how some variable affects different countries at the same time or according to their specific characteristics. So panel data is, if you want to publish an article, using panel data tends to give you an advantage as compared to cross-sectional data and time series. And just put a table here as an example. So different years, different countries. So you have like GDP. Here was GDP data for each country for each year. This is not a very large panel, so I just have 5 countries, 5 years. It's not very big. In real life, usually when we're analyzing real data, we tend to use longer series, 10, 20, 30 years if we can, instead of 5 countries. It depends on what you're trying to find. So like if I'm looking at emerging markets, I can put 15, 20 countries if I have data for that. And if I'm looking at something like public policies to solve poverty, and I observe that some countries have used a certain policy and some countries don't. So I can compare them all in a panel data set, so I can see the difference between them, see what changes have affected some and not others, and try to find a coefficient that represents that variation. So those are the 3 main types of analysis that we have in econometrics. And we're going to talk about building models in time series and panel data, because if you have cross-section, you can't predict something over time if you only have one period in time to observe it, right? So cross-section serves for you to see proportions or things that are new that you don't have historical data to make analysis about. But usually time series and panel data are the ones that we use the most, and panel tends to be the most used for larger articles when the data is appropriate for that type of analysis. So if you are ready, we're going to move on to our next class, which will be time series analysis. Okay, let's go.